Stationary point, differentiation. Example 7. A. Y equals x to the power 4 plus kx cubed plus x squared plus 17 has only one stationary point. Show that k squared is less than 32 over 9. B. Find the stationary point coordinate and state if it is maximum or minimum. If we have a function in the form of x to the power of n, dy dx equals nx to the power n minus 1, and d2y dx squared equals n into bracket n minus 1 x to the power n minus 2. This is the first derivative, and that's the second derivative. This is differentiation. This is rate of change of gradient. This function, we need to have it in this format, and then we can apply differentiation. We're talking about stationary point. That means the y dx will be equal to 0. So let's have our function our function here in this format. Y equals x to the power 4 plus kx to the power 3 plus x squared plus 17. A constant in this case, 17, is also 17x to the power 0, where x to the power 0 equals 1. Therefore, 1 times 17 is 17. So this is x to the power 0. Now we can apply dy dx. dy dx will be equal to 4 times 1 x 4 minus 1 to the power 3 plus 3 times k 3k x to the power 3 minus 1 2 plus 2 times 1 2 x to the power 2 minus 1 1 plus 0 times 17, that's 0. Therefore, dy dx equals 4x cubed plus 3kx squared plus 2x. At the stationary point, well, dy dx equal to 0. Therefore, 4x cubed plus 3kx squared plus 2x equal to 0. X is a common factor here, so we just take x out and we get 4x squared plus 3kx plus 2 equal to 0. I can see x equal to 0 and 4x squared plus 3kx plus 2. Well, if x equals to 0, then this has to be less than 0 because it's not a real root. Quadratic is ax squared plus bx plus c equal to y. If this solution has no real root, then the quadratic has a solution that says x equals to minus b plus or minus square root b squared minus 4ac, that's the discriminant, in the square root divided by 2a. So the discriminant here has to be less than 0 if it doesn't have real solution here, because that's what this is telling us. It's only got one stationary point, and that one stationary point is when x equal to 0. That's real root. So that has real roots. But in this case, it doesn't have real root. So the discriminant here, which is b squared minus 4ac, must be less than 0. The discriminant is the value here. In this case, we know that A equals 4, B equals 3k, and C equals 2. Therefore, applying those values in here, we get 3k squared minus 4 into bracket 4 into bracket 2 is less than 0. 3k squared is 3 squared is 9. K squared is k squared minus 4 times 4, 16 times 2, 32, less than 0. Add 32 to both sides, or take minus 32 to the other side. 9k squared, less than 32. If I divide both sides by 9, 9k squared less than 32. If I divide both sides by 9, k squared is less than 32 over 9. And that's the proof that we need to show. B, find the stationary point coordinate and state if it is a maximum or minimum. We know that we've got the real solution here, x equal to 0. So x equal to 0. We need to then find the 2y, the x squared. At the stationary point, x equal to 0. The 2y, the x squared, will be equal to, in order to determine if it's maximum or minimum, we need to find the second derivative. And so we're differentiating that again. So that will be 3 times 4, 12x squared, plus 2 times 3k, that will be 6kx, 1 times 2 plus 2. So that will be to power 1, x to power 0. We know x to power 0 is 1. 1 times 2 is 2. If you have a 0, dy dx equal to 0, that means it's horizontal gradient. That's stationary. And that could be minimum or maximum. We don't know. And that's what we're trying to determine. So that it's stationary because it's horizontal. If it goes, second derivative goes positive, well, that would be a minimum. So that's minimum. If the second derivative goes negative, then that is maximum. The 2y, the x squared, is less than 0, or the 2y, the x squared, is greater than 0. That's positive, negative, positive. So minimum, maximum. So we're going to determine that now by substituting x into here and find the value. So the 2y, the x squared, when x equal to 0, will be equal to, if x is 0, that will be 0, and if x is 0, that will be 0, which means the 2y, the x squared, is 2. Now that's positive, which is that one, which means it's minimum. The question states we should state, is it a maximum or minimum? We now know that it is a minimum. So remember, that's a stationary here, the red one. In this case, that's positive gradient. This is negative gradient. So you've gone from 0 to positive, that's minimum. If you go from 0 to negative, that's maximum.